Good day. In this video, the group 12 with Ali, Copreros, and Martinez will be discussing about the psychological assessment on its some topics, including the measures of variability, skewness, kurtosis, and the normal curve. Now for the topic outline, we will have for the measure of variability, the range, interquartile range, semi-interquartile range, average deviation, standard deviation, and the variance. For skewness, the positive and the negative skew. For kurtosis and its three kinds, Platykurtic, Leptokurtic, and Mesokurtic. And for the normal curve, we have the Laplace-Gaussian Curve. Now at the end of this video, the audience are expected to answer the following questions. What are the different measures of variability and their uses? What are the skewness or what is skewness and its variations? What is kurtosis and its variations? And what is normal shaped curve? Almost all of the terminologies in this video are already familiar to us since we have already discussed the overall topic during the psychological statistics era. So moving forward, before we measure or we tackle the measures of variability, we have to first identify what is variability. So it is an indication of how scores in a distribution are scattered or dispersed. Referring to the figure 3 to 4, we have two different distributions, namely the distribution A and the distribution B. You can see there that both have the same mean, which is 50, but then for distribution A, the rest of the scores are widely scattered from 0 to 100, while in distribution B, only few got above 60 and below 40 of scores. Now, the measure of variability is any statistics that describe the amount of variation in distribution. This includes the range, the interquartile range, the semi-interquartile range, the average deviation, and the standard deviation, and lastly, the variance. For the range, we have a formula of the difference between the highest and the lowest scores, or simply the highest score minus the lowest score. So on the given figure just a while ago, the figure 3 and 4, we can see there that on the distribution B, the highest score is 60 and the lowest score is 40. And following the formula for the range, we could acquire a range of 20. Or simply 60 minus 40 equals 20. And for the distribution A, with highest score of 100 and the lowest score of 0, we can say that the range is equal to 100. So the range is the simplest measure of variability to calculate. But then its use or its potential use is limited because the range is identified or based entirely on the lowest and the highest scores. Then one extreme score can radically affect the value of the range. For instance, let's say on the distribution B, there is a score of 90. So the highest distribution or the highest score now is 90 and then the lowest is 40, or equal to now the range, which is 50. Yet, looking at the data and the graph of the distribution B, it is clear that the vast majority of the scores tend to be between 60 and 40. So there will be a confusion created with that. Next is we have the interquartile and the semi-interquartile ranges, or the division of test scores, or any data for that matter, into 4 parts, or the 25% of the test scores. Now, an interquartile range is a measure of variability equal to the difference between the quartile 3 and the quartile 1. And like the median, it is an ordinal statistic. Or the interquartile range is similar to the mean of the data. Okay, it is denoted the quartile 2, or as you can see on the graph, the center point or the center division of the graph. And for the semi-interquartile range, it is related measure of variability, which is equal to the interquartile range, but is divided into 2. Or as you can see on the graph, we have 4 different quarters there. So that is the semi-interquartile range. Now, the importance of interquartile and the semi-interquartile ranges are that they are your guide upon seeing whether, or initially seeing whether your graph will be a normal curve, or if, for instance, if there are differences or abnormalities in your data, then you will have the skewness. And later we will be talking about the skewness. But for now, we have to move forward to the average deviation, or is another tool that could use to describe the amount of variability in a distribution, and is often labeled to as AD for short. It has a formula of AD equals to the quotient of the summation of x and n, whereas the lowercase italic x is the difference of mean and in the score, or having the formula of x minus mean equals the lower italic or lowercase italic x, whereas the bars on each side of the x indicate the absolute value of the deviation score, meaning that there is no negative algebraic sign presented in the overall data. So we have here an example of the data, which is having 85, 100, 90, 95, and 80, with a mean of 90 and the summation of x, which is 30. And since you see the number are only 5, so we will substitute n to 5. So substituting all the elements to the formula, we can get an AD, or the average deviation, of 6. Now, it is also said that the average deviation is rarely used. Perhaps this is so because of the deletion of algebraic signs renders it as a useless measure for purpose of any further operations. So rather than using average deviation, we are going to use its cousin, which is the standard deviation. And a standard deviation can be calculated with the same problem dealt with the average deviation, but instead of using the absolute value of each deviation score, we use the square of each score, and having the formula standard deviation equals the square root of the quotient of the summation of x squared minus the over the n minus 1. Now, why do we have here n minus 1? Because it is believed that the n minus 1, or the number of the data sets minus 1, will result to a further unbiased data or unbiased result. Now, as to when the data, or when the number of the scores in the test set is 10 or below 10, then the n minus 1 and the n, or the use of the denominator n minus 1 and or n, will have no meaningful differences at all. And also, on the previous course, the psychological statistics, it has been presented very well that we have two different equations used for standard deviation and variance depending on the nature of the data. So now we are going to use a sample, or the formula for the sample, which is presented on the screen. And also for the population, we will have different formula, which is quite similar, but only the difference is the standard deviation is denoted as the Greek letter sigma, and then the denominator is just n and not n minus 1. So again, going back to our sample, substituting all the elements to the formula of the standard deviation for sample, we can acquire a standard deviation of 7.905. And since the variance is the square root of the standard deviation, then the variance of this set, or the sample set, should be 62.649, respectively using the formula for the sample variance presented in there. Now, there are also different ways upon getting the variance. And it is, for example, for the raw scores, first you have to calculate the summation of the raw score squared, and then divided by the number of scores, and then subtracted by the mean squared. Or to further understand this, there in your module, you have there a table. There is a presentation of table in there. And also the calculation was also presented on how to use that type of formula. But since we have the standard deviation calculated a while ago, we have only used the simpler term. So the skewness is an indication of how measurements in a distribution are distributed, or the nature and extent to which the symmetry is absent. And we have two sets, or the two types of skewness, the positive skew and the negative skew. Positive skew is defined as the distribution that has a positive skew when it is relatively few of the scores fall at the right end of the distribution. So as you can see on the left side of the figure, this slope is falling to the right side, or that is now what we call the tail of the graph. So since the tail is facing the right side, or the high end of the distribution, then we can consider it as a positively skewed or positive skew. And opposite is true to the negative skew, which is when the relatively few of the scores fall at the low end of the distribution, then that is the time you can consider it as a negative skew. Or simply the tail is facing on the left side, so that's the time that you can say it is negative skew. Also, the term skewed carrying a negative implication to many students, since the skewness is quite linked to the abnormality of the data set or the test scores on the set. So that's it. Moving forward, the kurtosis is a term used by testing professionals to refer to the steepness of a distribution in its center. So the root kurtic is added to one of the prefixes platy, lepto, or meso to describe the peakness or flatness of three general types of curves. So referring to the figure 3 of 6, the distributions are generally described as, for the broken line there, you can see on the graph there is a broken line, it is called as a platykurtic, which is a relatively flat center, or the distribution in the center is relatively flat. So for the black line, continuous line, you can see there, very high on the middle. So it is known as the Leptokurtic, which is relatively peaked somewhere in the middle. And for the continuous blue line, it is denoted as the Mesokurtic, or somewhere in the middle. So this is the last topic on today's video, the normal curve. So a normal curve is conceptualized, or its concept has begun in the middle of the 18th century with the work of Abraham du Moivre and later the Marco de Laplace, now known as the Laplace-Gaussian Curve. In the modern textbooks, you could encounter normal curve as the term used to this type of graph. However, there are some mathematicians still prefer the use of Laplace-Gaussian curve. Now, the characteristic of a normal curve is bell-shaped, smooth, mathematically defined curve that is highest at its center. And from the center, it tapers to both sides, approaching the x-axis asymptotically. When we say asymptotically, it defines to the approaching to the line. However, it is not touching the axis or the x-axis, for instance. Now, there are different areas under the normal curve. First is the normal curve can be conveniently divided into areas defined in the units of the standard deviation. So there's actually a theory that when you try to fold the curve into two, you will see that there is a symmetrical slope, you will see, and that's the time you can say that it is a normal curve on the graph. Next is a hypothetical distribution of national spelling test scores with a mean of 50 and a standard deviation of 15 is illustrated in the figure 3.7 there, the graph there. In this example, the score equal to the one standard deviation above the mean would be equal to, you see there, the equation presented on the screen. Now, there is an interpretation you can see on the figure 3.7, where you can see on your module. However, it is said here that the analysis of the normal curve is that 50% of the scores occur above the mean and 50% of the score occur below the mean. And the approximately 34% of all scores occur between the mean and one standard deviation above the mean and one standard deviation below the mean, as you can see there on the figure. And also, that is approximately 68% of the scores occur between the mean and the positive negative 1 standard deviation. There is a clearer picture you can see on the module. You have it has been given to you. And also, an approximately 95% of all scores occur between the mean and the positive negative 2 standard deviations. Also, another fact of the normal curve is that it has two tails. The area on the normal curve between 2 and 3 standard deviations above the mean is referred to as the tail. The area between -2 and -3 standard deviation below the mean is also referred to as the tail, as you can see there on the graph. So that concludes all the discussion in this video. And lastly, we have to have a summary, and there we will going to answer the questions presented just a while ago. So what are the different types of measures of variability and their uses? So we have the range, we have the interquartile and the semi-interquartile ranges, and their uses are for you to have the hint of what will be your graph will look like. And then we also have the average deviation, which is quite confusing and is not really advisable to be used because of the absence of the algebraic sign, the negative, and rather we are going to use the absolute value. Okay, so there is the use instead of its cousin, which is the standard deviation, having two different formulas, same as with the variance, depending upon the nature of the study or the nature of the graph. For the sample, we can have the standard deviation denoted as either lowercase s, capitalized S, or capitalized S and D, which is equal to the square root of the quotient of the summation of x squared and n minus 1. And for the population, the standard deviation is denoted with a Greek letter sigma. And then the denominator of the formula is not n minus 1 but just n. So for the variance, the square root of the standard deviation is equal to the variance. So very easy. And then we have the other formula that can be used for the raw data, which can be seen in your module there. So you can free view it. So next question is, what is skewness and its variation? So skewness is an adjective used to describe your graph, and it has two different variations, the positive and the negative skewness, which is depending upon where the slope or the tail of your graph is facing, is how you are going to identify it. So the third question is the kurtosis and its variations. So we have, it is also an adjective used to describe your graph, and it has three variations, which is the we have here the Platykurtic, which is relatively flat curve, and Leptokurtic, which is relatively peaked somewhere in the middle, and the Mesokurtic, which is somewhere in the middle, or in the middle of the relatively flat or the Leptokurtic. Now for the last topic, we have the normal shaped curve. So a normal shaped curve has a characteristic of a smooth, mathematically defined curve that is highest at its center, that when you fold it in half, the slopes are symmetrical, and that the x-axis is tapers both sides asymptotically. Or meaning is it approaches but never touches the axis or the x-axis. So that concludes the overall the summary of the topic in this video, and good day.